So this is October 2023 paper. And question number one, which method would be most suitable to investigate the kinetics of the reaction shown? Like we have to discuss the rate of reaction of this reaction. We have different methods to determine the rate of reaction. Like we can see the color, like we can see the change in temperature, right? Or like we can see the pH changes. These are physical methods. Despite that, they are not so much accurate methods, but of course they are asking the question and the options are given to you. So what do you think, which is supposed to be the best option for this? Since in the question we have to see, is there any colored compound or not? Is there any colored compound or not? If there would be any colored compound, then of course we would be looking at the color of that particular compound, right? But I don't think so that in the question there is a colored compound, because this is going to be alkene. So this is colorless. Hi is colorless. Iodine is colored. This is not iodine. This is Hi, like iodide ions. And this is going to be the halogenoalkane. Yes. So I can say we can measure the volume of gases, isn't it? How much volume of a gas is produced per unit time. Let's suppose I have a stopwatch and I'm looking at how much volume is being produced, and I have a gas syringe or anything else, we can collect that particular gas. Because we can't choose colorimetry because there is no any colored species in this, right? So option B is correct. Option B is correct. And I can't say that option C is going to be correct because uh, this option would be correct if there would be any solid species, but there is no. And in option D, quenching with ice cold water followed by the titration with acid, there is no base, isn't it? There is no base. So that's why option B is the best. Then another reaction they have given to you, right? And also you can see there is nothing colored, isn't it? So I can't select colorimetry. Okay, I can't select colorimetry. Then I have to see option B, measurement of change in volume. Measurement of change in volume. There is no gas. There is no gas. Measurement of change in mass. There is no solid. So option D is left. So that's the correct option. Okay. Quenching with ice cold water followed by titration with acid. How much sodium hydroxide have been consumed? So we can calculate the amount of sodium hydroxide by titrating with any acid. Okay. And meanwhile, when I will be doing the titration, so the reaction should be stopped. Okay. So what can I do for this one? So they are saying quenching with ice cold water. So if you will be decreasing the temperature of this reaction, so of course the rate of reaction would be slower. Okay. So D is correct. Question number two, the equation for the reaction of bromate 5 ions with bromide ions in acid solution. The rate equation for the reaction is this. The concentrations of all the reactants are doubled. By what factor does the rate of reaction increase? So we are doubling each and everything, right? Because they are saying all the reactants are doubled. So if this is doubled, okay, this would be 4 times. If this is doubled and if this is doubled. So what would be the final answer? 4 into 2 and then into 2, isn't it? So I think the correct option would be D for doctor, isn't it? Because this is going to be 4 into 2 and then into 2. So options D is correct. Okay. Because this is supposed to be power 2 and this is going to be 2 and this is also 2. So it's going to be 16. That's why. This question is about rates of chemical reactions. Which graph shows a reaction that is zero order with respect to reactant Q? Zero order, zero order means that when concentration changes, but the rate remain constant. When the rate remain constant, it's mean that the reaction is zero order. Okay. So what do you think which graph is supposed to be correct in which you can see the rate is not changing? Since the graph they have given to you is with respect to reactant Q. This is concentration time, rate versus concentration, concentration versus time, and the rate versus concentration. Yes. So what do you think which graph is supposed to be correct? And keeping in mind what is the zero order reaction? We have zero order, we have first order, we have second order. So, and also, for a zero
It
order
would be
reaction,
A.
why?
Hello.
Why A is correct? Why A is correct? Hmm?
Sir, your
Yes,
voice is breaking. I can't hear you.
I'm saying why A is incorrect. I'm saying why A is incorrect. Yes. Now, can you
Incorrect
hear me? Yeah, A is correct, but why? Hmm?
because you
A is
said it's zero order, so like the concentration changes over time.
zero order. I told you that when the concentration will change, but the rate will be unaffected. It's mean that this is going to be zero order. And also for a zero order reaction, the gradient will remain constant. The gradient will remain constant for a zero order reaction. Okay. So gradient means gradient is equal to concentration versus time. So of course I would be looking at this one and this one. Okay. But this is not supposed to correct because the concentration is constant. Time is changing. The concentration is constant. No. Zero order doesn't mean that when the time changes but the concentration remain constant. No. Concentration can change, but the rate remain constant. So if you can see in this graph, when you will be finding out the gradient, so the overall gradient would remain constant because the line is straight. Because the line is straight. So yes, this is going to be zero order reaction. So basically, this is fulfilling the definition of a zero order reaction. That's why A is correct. The equation for a gas phase reaction is shown. The reaction is first order. Okay. When the initial pressure of A is 2 atm, the half-life of the reaction is 20 seconds. What is the half-life of the reaction when initial pressure of A is 4 atm? Yes, when the initial pressure is 4 atm. And since they have told you that the half-life of the reaction is 20 seconds and they are saying the reaction is first order, right? They are saying that the reaction is first order. So when the initial pressure of A is 2, okay, so what is the half-life of the reaction when the initial pressure of A is 4 atm? If you remember, if you remember in terms of half-life, in terms of half-life, what we used to say for a first order reaction, the half-life is supposed to be constant. Like let's suppose if I have first half life, if I have second half life, so I should get the constant value. If they have given you the half life that is supposed to be 20 seconds, of course the second half life is supposed to be the same, that is 20 seconds. So means that option B is correct. So means that option B is correct. Okay. And this question says the graph shown can be used to obtain a value for the activation energy of a reaction, ln rate constant and 1 by T. in terms of Kelvin. The activation energy is related to the rate constant by the equation from the graph. The EA is equal to this one. So we know that Y is equal to mx plus c. We know that x like m is the gradient. We know that m is the gradient. When m is the gradient, so it's mean that when m is the gradient, so it means that like gradient is equal to minus EA upon R, isn't it? So the gradient is equal to minus EA upon R, right? Okay. So so the answer is supposed to be EA would be equal to EA would be equal to gradient times R negative, right? So the answer is C. Very easy, okay? But for this one, you need to know the equation that is y is equal to mx plus c, okay? Question number 5. The energy cycle for dissolving calcium chloride in water is shown. The enthalpy change of hydration of the calcium ion is 1650 kilojoules per mole. What is the enthalpy change of hydration in kilojoules per mole of the chloride ion? You know, what's the formula for the delta H of solution that is supposed to be Hyderabad minus Lahore? So it's supposed to be hydration minus the lattice energy. Hydration minus the lattice energy. Okay. So what I would be doing in this one, since they have given you the solution that is minus 120, that is minus 120, and I have to find out the hydration for the chloride ion since this is going to be 2x. And for the calcium, I think, yeah, for the calcium, they have not given, right? The hydration for calcium is not given. Uh, no, given. Minus 1650 is the hydration for calcium. So it's going to be minus 1650 plus 2x minus lattice energy. Lattice energy is minus 2258. So the answer for x would be equal to, let me let me simplify this. It's supposed to be minus 120 plus 1650 minus minus uh plus minus double 258 is equal to 2x. Okay. So what is the answer for x? Yes.
It's minus 364.
It's minus 364. Okay, good. Why is the enthalpy change of hydration for magnesium ions more exothermic than that for the calcium ion? Since we know that down the group size increases for the cations like magnesium, calcium, strontium, barium, right? So number one is magnesium ion has a larger radius as compared to calcium. No, down the group size decreases. Magnesium ions, sorry, increases. So magnesium ions form stronger ionic bonds with what? Yeah, it's true that they are going to form ionic bond, okay, but this is not related to the ionic compound, right? In the hydration, what's going on? The ions, it's surrounded by the water. So in C, they are saying magnesium ions have a higher charge. Yeah, that is supposed to be correct. Why? Because when the cation has a lower size, so it's mean that it would be having the higher charge density. And when it has a higher charge density, so it means that it would be releasing more energy. Okay, so that's why the hydration for this one is going to be more exothermic. Okay. Heating copper nitrate results in the equilibrium shown, which is the expression for Kp. Kp is equal to, again, I would say product upon reactant. In Kp, we are not supposed to include solid. Okay, in Kp, we are not supposed to include solid. So it is going to be Kp is equal to concentration of product, like, sorry, partial pressure of NO2 raised to the power 4 multiplied by partial pressure of O2. There is no reactant because reactant is solid and we do not include solid in this Kp expression. So it's supposed to be C. No, 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 no. It's supposed to be D for doctor, right? Okay. Or what can I say? When concentrated hydrochloric acid is added to methanoic acid, an acid-base reaction occurs. An acid-base reaction occur, right? So what are the Bronsted-Lowry acid-base conjugate pairs in this equilibrium? Acid-base conjugate pairs. And according to Bronsted-Lowry theory, we know that acid is a proton donor and base is a proton acceptor. According to the like Lowry-Bronsted theory, okay? So what do you think? HCl is donating proton, right? So it's a conjugate acid, isn't it? And HCOOH is gaining protons. Is gaining one
So
proton.
it's gonna be
So it's
conjugate base,
conjugate
and then
term is only used in the product side, remember.
yeah. So the HCOH would be conjugate base of
So this is
acid
going to
two.
be acid 1, right? This is going to be acid
Yep,
1. So acid 1 is, oh,
yep,
all are HCl, okay. And
yeah.
acid 2 is going to be this one, isn't it? Because it would be donating its proton because it has one more proton. So I have to see option A and D. Right. So then I have to see conjugate base and conjugate acid too. Okay. So, it's not a base. Why? Because it has an ability to donate proton. Right. So it's not a conjugate base of acid 1. So the conjugate base of acid 1 is Cl minus. So D is correct. There is a hint for this one. When acid gives its proton, so it becomes a conjugate base. So it's a common sense. The conjugate base of HCl would be Cl minus, not the HCOOH. At 100 degrees Celsius, pure water has a pH of 6, but at 25 degrees Celsius, it has a pH of 7. This is because the dissociation of water is endothermic. Yeah, this is true that the reaction of like the dissociation of water is endothermic. Okay. And what's the concept behind this? Like why the pH is affected by the change in temperature? So when the temperature decreases, it's coming from 100 to 25 degrees Celsius. Okay. So when the temperature decreases, since the reaction is endothermic reaction wants temperature because when you will be providing the temperature, so the reaction will be moving forward. Okay. So it would be dissociating more, but they are going to decrease the temperature. When they are going to decrease the temperature, so I would say that the dissociation becomes lower. When the dissociation becomes lower, so the concentration of H positive ion will become lower. And when the concentration of H positive ion decreases, so the pH increases. Okay, that's the concept. So I would say like this reaction is endothermic. So when the temperature decreases, so dissociation decreases. So the concentration of H positive ion decreases and the pH increases, right? So this is because of what? The dissociation of water is endothermic. This is endo and this is endo. This is exo, this is exo. So we have to select option A and D, any one of them. So the concentration of H positive ion is lower at 100. No, I told you when the temperature increases, so the dissociation increases. So means that it is supposed to be C. Because when the temperature is like, I would say that they are saying the concentration of H positive ion is higher at a higher temperature. Because what I told you, when the temperature is lower, so the concentration is lower. But in this question, they are saying at 100 degrees Celsius means that the temperature is higher. And when the temperature is higher, so the concentration of H positive ion would be higher. And what about this one? See this question number 9. Four beakers each contain equal volumes of four solutions. Beaker 1 contain 0.01 mole per dm cube NaOH. Beaker 2 contains the same but ammonia. Beaker 3 contain zero point 0.1 mole of NaOH. And beaker 4 contain zero point 0.1 mole per dm cube barium hydroxide. Since sodium hydroxide is a strong base, right? Sodium hydroxide is the strongest one. And ammonia is the weaker. Okay. So the pH of the four solutions was measured. Which of the following gives the order of decreasing the pH? So what I can do, they are saying which of the following gives the order of decreasing the pH? Like higher to lower, like higher to lower. So yes, it's quite clear question. What do you think? And ammonia is the weakest among these all, remember. And they are saying which of the following gives the order of decreasing pH? You know, decreasing means that ammonia is the weakest base. Ammonia is the weakest base. So the pH of ammonia would be the weaker, isn't it? Would be, I can say, near to 7. You know, when the base is lower, so the pH would be near to 7. So we have two options, C and D. We have two options, C and D, because in these two options, there is a 2 written. Now we have to decide which one is correct, C or D. In C, they are saying 3. 3 is the sodium hydroxide. And in D, they are saying this is 4, and 4 is the barium hydroxide. So now we have to decide which one is the strongest and which one is the weaker. Okay. So first of all, we have to see the concentration of OH negative ions. In sodium hydroxide, the concentration is 0.1, but in barium hydroxide, the concentration is 0.2. You know why I'm saying 0.1 multiplied by 2. So when you will be finding out the pH, so you will see that the pH of barium hydroxide would be higher. So it's supposed to be D. You can just find out the pH. Then you will see the answer. The pH of 0.1, like the negative log of 0.1 and the negative log of 0.2. So you will see the difference. Okay. So the answer is D. Are you getting my are you getting me?
Yeah.
Okay. This question is about the reaction scheme shown. Which reagent is required for reaction 1? And what's going on in reaction 1? We have to see this first. Like from reactant to product. The reactant is carboxylic acid. The reactant is carboxylic acid. And what's the product? What's the product? Yes. Can't you identify the product? Yes. Can you hear me? Hello. Hello. You're muted.
Sorry, your voice was just a bit crackly at the start.
So I was asking, what is this compound? Like this is carboxylic acid. So what is this?
Esther.
Ester. No, it's a primary alcohol.
Oh, sorry, I was reading the reaction three, not the this one. That's why.
Okay, what do you think? What is supposed to be the answer? And we can see that carboxylic acid is changing into the primary alcohol. So I think this is
We
supposed to
need
be
like
reduction.
Li. We need the LiAH in the dry ether, so it's gonna be D.
Like it's a reducing agent, right?
Yeah.
Yes. Lithium aluminium hydride, which is a reducing agent. So that's why. Reaction 1 has a high yield of 90%. Okay. What mass of 2-methyl propanoic acid is required to produce this one? So this is very easy. You can calculate this, then you can see my working, what I am doing. Percentage yield, actual upon theoretical, of course, multiplied by 100. And for the percentage yield, the one which we are going to find out, we must have the two masses so that we can divide the two masses to get the percentage yield. So, they are referring the reaction 1. So in a reaction 1, this is our product. This is our product. That is an alcohol, right? So Um, 2-methyl propane 1-ol is the product. And of course, we have to find out the percentage yield of this alcohol. So we must have the two masses, right? So what I'm going to do, I'm going to find out the moles of the given mass, 6.66 upon 74. So what I'm getting, 6.66 upon 74 is what's the answer? 0.0, 0.0 what? For the moles of propane 1-ol, like 2-methyl propane 1-ol. Are you calculating this? What's the number of mole if I'm going to divide 6.6 upon 74? Yes?
It's 0.09.
Okay. Since we know that percentage yield is equal to actual upon theoretical multiplied by 100, right? So we have given the 90% yield, that is this, and I have to find out the theoretical mole. Actual moles, they have, like we just found that was 0.09. I have to find out the theoretical value. So the theoretical value would be equal to 0.09 over 90%. So the answer would be zero point 0.1 mole. So the answer would be zero point 0.1 mole. And what I'm going to do, I'm going to take the mole ratio between acid and this alcohol, that is 1 is to 1. So the ratio is 1 is to 1. So this mole is of, I can say, um, mole of acid, right? So I'm going to find out the mass. They are asking the mass of 2-methyl propanoic acid. Okay, like they're asking the mass of acid. So to find out the mass, I have to multiply the MR with moles. So the MR of propanoic acid is 88 and multiplied by 0.1 would be equal to 8.8. So D is correct. Okay. Which condition is which condition is essential for reaction 2? Reaction 2 is this one, PCl5. Which condition is essential for reaction 2? Yes, for reaction 2. This is reaction 2, right?
Um, Yeah, anhydrous.
Yes, this is supposed to be anhydrous because the PCl5 is dry. It should be dried. If it is not, so the OH from water can interrupt the chemical reaction. Like in the presence of water, we would not be having the product that is going to be this acyl chloride. So this is the desired product, right? Okay, see this part D. Reaction 3 and 4 produce the same ester. See this? Okay. The ester is same. The formula is same. Which is an advantage of using reaction 4 to produce this ester and in the laboratory? Like you can see the reaction 4. That is acyl chloride, you know? So yeah, so we can convert alcohol into an ester and we can convert acyl chloride into an ester. And they are saying that reaction 4 is the like we have an advantage of reaction 4. For this reaction, we need to know the nature of acyl chloride, you know. Acyl chloride is more reactive than carboxylic acid. Acyl chloride is more reactive than carboxylic acid. Okay. So if this is more reactive and generally in an esterification, what we do, we provide temperature, we provide catalyst, you know. So it can be carried out at a room temperature. This is due to the greater reactivity of acyl chloride as compared to the carboxylic acid. That's why. Okay. Question number 11. Which diagram shows two repeat units? Which diagram shows two repeat units of the polymer formed by the polymerization of propane 1,3-diol and benzene 1,4-carboxylic acid? Of course, this is a condensation polymerization, right? So they have given you the monomers as well. They have given you the monomers as well. So we can decide on the basis of these two monomers. So you can try this. This is very easy. Since we know that when the polymer is formed, so the alcohol will give its H positive ion, like, sorry, yeah, OH, and carboxylic acid gives H ion. Like the water is removed. The water is removed because condensation means when water is removed as a side product, right? As a side product. So we can just form an ester like polymer. I'm drawing the structures. Propane 1,3-diol. This is going to be diol, and this is the carboxylic acid. So you will see that uh, this is going to be removed, and we have to see the aster linkage. We have to see an aster linkage. Okay. So um, two repeat units. This is only one repeat unit, right? And this is incorrect because on the one side we must have an alcohol and on the other side we must have a carboxylic acid. This is wrong. And let's see option C. Uh, this is wrong because with propane 1,3-diol, there is no carbonyl compound. This is nonsense option. Of course, option D would be correct. This is one and only option left. Okay, all are wrong. Polymer waste may be disposed of by incineration at a plant carrying out this process. With polypropene, a waste gas was produced that was thought to be either propane or carbon dioxide. These compounds have the same molecular ion peak in a low resolution mass spectrometer but can be separated at a high resolution. They have given you the relative mass as well, right? What are the correct relative molecular masses? Yep. So for carbon dioxide and also for the propane, since we know the formula for propane, that is going to be C3H8. C3H8. Yes. And they have given you the masses as well, right? Like let's say for carbon dioxide, I would say that first of all, I have carbon. Carbon is 12. Carbon is 12.0000 plus we have two oxygen atoms, 2 into 15.9949. So the answer is going to be 43.9898. And if you can see for the propane, that is C3H8, carbon is 3 times 12.000 plus 8 multiplied by 1.0079. So after all, you would be getting 44.0632. So it's D. So it's D, right? Oh, yeah, okay. A thin layer chromatogram of a mixture of two compounds X and Y is shown. What is the RF value for compound X? What is the RF value for compound X? So what I would do for this one, I would be taking the ruler and I have to find out the distance of X through the baseline. Distance of X through the baseline, okay? So, and you know what is the formula for RF? That is distance of X divided by the distance of solvent. Distance traveled by the solvent, by the way, okay? Or it's not in the mid, it's not in the mid and it's not too lower. So we can also take an idea. Otherwise, you can calculate this. Otherwise, you can calculate this, right? So this is 0. This is 0 and the distance of this X is going to be 3.56789, 3.9. And the distance of solvent would be 10.6. Can you divide it? Can you divide it? Yes. What's the answer? But fast. Fast. Fast.
It's 0.37.
Like B is correct. Okay, so B is correct. Y traveled further than X. Okay. How do the attractions between y and x to the stationary and a mobile phase compare? How do the attractions between x and y? So they are saying y traveled further. Y traveled further means that it has a lower affinity with the solvent, isn't it? Right? Like it has a greater affinity with the solvent, by the way, because it's having more distance. In option A, they are saying x like sorry, attraction between y and the stationary phase is stronger. No, if if the attraction between stationary phase and y would be stronger, it would not be traveling more. Common sense. A is incorrect. Let's see option B. X attraction between y and the stationary phase is stronger. No, 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 it's not stronger. We have to see the weaker. We have to option C and D. Is weaker than the attraction between x and the stationary phase. Yeah, that is supposed to be correct. Then we have to see another one as well. Attraction between y and the mobile phase is stronger. Yeah, this is correct. Because that's one of the reason it's traveling more in the presence of that particular solvent, isn't it? Right? So that's why C is correct. So this is concept, like when something travels faster, when something travels lower, so you have to think about that. You can you can go through the affinity of the solute towards the solvent. Okay? So that's all for section A.